Howdy! This is Electricity Physics Review Video number 12. Okay? It's Electricity 2, I should say. So, we talked about electricity a little bit. Electricity, electrons in motion, they're boogieing, they're moving. So we need some kind of path for them to move in. So we talk about, just to review here, because this is all review, you know all this stuff, right? So, series circuit. Series circuit is going to look like this. So if you watch a TV series, you watch one show after another. If you miss one, you're kind of bummed, and you go back and probably see it, catch it on the DVR or whatever. So, say for instance, this is your 24 volts here. This is 2 ohms, 4 ohms, and 3 ohms. Then what would happen is, if we wanted to find the total or equivalent resistance in series, we add them up. Right? So we'd add up these, and it would be 2 plus 4 plus 3 is a total of 9 ohms. And then our voltage is going to be, the total voltage will be the sum of these. And then our current will be what? One path. Current is going to be all the same throughout. Okay? So, part of our song, remember? Volts, ohms, and amps, you must be careful with volts, ohms, and amps. With the voltage to jolt, the resistance to gulp, 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 and the current begins to flow. And then series, voltage has to be shared. Current, it's the same everywhere. Resistance, each one takes its own part, and the current returns to start. And then the parallel one we'll sing about in just a minute. Which one of these would take the most voltage? Well, I'm thinking this one has the greatest appetite. It's like kids at the table. Remember, you're looking down from above, and you're seeing this is the pretty hungry child right here. It doesn't have anything to do with where they are in the order. It just has to do with their resistance. Okay. And the other thing that we need to know about in terms of measuring is it would only take 1 ammeter to measure the current here, because that's going to be all the same. And ammeters, if you look, they're right in series, connected in series with everything, or in line with it, because the current's going to be the same in series. You want the electricity to flow through there. And the resistance for this little guy, do you think you'd want it high or low resistance? Think about that for a second. If you want this to be in here and make a measurement but not mess it up, you want it to be low resistance. Low to allow it to flow on through. Okay? Go with the flow. So series, one path, no choices. Parallel. So say we had the same type of thing, except now we have parallel. So your circuit here, your electrons are going to have some choices to make. It's like these career choices they can make. 24 volts. So if this one's 2 ohms, this one's 4 ohms, and this one's 3 ohms, where do you think most of the electrons are going to go? They will go, just like people, on the path of least resistance. Not because it's first, but because it's least resistance. And if you want to measure the total current in this circuit, you're going to have to measure like here or here. Because if you measure here, here, or here, you're only going to get part of it, the part that goes through that part. The part that goes through that, section of the circuit. Now your voltage here is all the same. Remember that? I hope so. And your current, your total current, is going to be what comes down 1 plus 2 plus 3. So it's the sum of those. And your resistance, the equivalent resistance in parallel, you actually add up the reciprocals. So, whoops, didn't mean to do that. So 1 over R1 plus 1 over R2 plus 1 over R3. And if you remember this, in parallel, the total or equivalent resistance is smaller than the smallest one. So it should be less than 2. So check that for yourself, and it should be less than 2. So my song for that is parallel voltage.